Based on the position of constituent particles in a unit cells are broadly classified into primitive unit cell, centered unit cells. Primitive unit cells. When constituent particles are present only on the corner positions of a unit cell, it is called as primitive unit cell. It is denoted by the letter P. Centered unit cells. When constituent particles are present not only at the corner positions but also at some other positions within the crystal, then the cell is known as centered unit cell. Centered unit cells are further classified into body-centered unit cell, face-centered unit cell, end-centered unit cell. Body-centered unit cell. In this type of unit cell, one constituent particle such as atoms, molecules or ions is present at the center of the unit cell, in addition to the particles present at the corner positions. Body-centered unit cell is denoted by the letter I. In face-centered cubic unit cell. In this type of unit cell, the constituent particles are present not only at the corners but also at the center of each face of the unit cell. Face-center unit cells are denoted by the letter F. Calculation involves in a unit cell. A crystal lattice is made up of a very large number of unit cells. Each unit cell is touching a number of other unit cells. In a unit cell, every lattice point is occupied by one constituent particle. Thus, a constituent particle present at the lattice point may be shared by a number of unit cells. Let us now understand the contribution of a particle in a lattice point to its unit cell. A corner atom is shared equally by 8 unit cells. 4 unit cells are present in the lower layer and 4 unit cells are present on the upper layer. Therefore, each corner atom contributes only 1/8 atom to a particular unit cell. A face-centered atom is shared equally by 2 unit cells having a common face. Therefore, an atom present at the center of the face of a unit cell contributes half atom to each unit cell. A body-centered atom is not shared by any adjacent unit cell in a crystal lattice. Therefore, it contributes fully to a unit cell. A edge-centered atom is shared by 4 adjacent unit cells in the crystal lattice. 2 unit cells are present in the lower layer and 2 unit cells are present on the upper layer. Therefore, it contributes only 1/4 of itself to a unit cell. Calculation of number of atoms per unit cells in primitive cubic unit cell. Simple cube. In simple cubic unit cell, there are 8 corners in a cube. There is 1 atom at each corner of the cube. Since each corner atom is shared equally by 8 unit cells, hence, each corner atom contributes 1/8 atom to each unit cell. Number of atoms in one simple cubic unit cell is equal to 8 into 1/8, which is equal to 1 atom. A simple cubic unit cell contains 1 atom. Calculation of number of atoms per unit cells in body-centered cubic unit cell. In a body-centered unit cell, there are 8 atoms at each corner positions and 1 atom at its body center. As each atom at the corner position contributes 1/8 to the unit cell, the contribution of those 8 corner atoms to the unit cell is 1 atom. The atom at the center of the unit cell is not shared by any other unit cell. Thus, its contribution to its unit cell is whole. Hence, the number of atoms per body-centered unit cell is 1 plus 1, which is equal to 2. 8 corner atoms into 1/8 is equal to 1 atom. 1 body-centered atom is equal to 1 into 1, which is equal to 1 atom. Therefore, number of atoms per unit cell is equal to 2 atoms. Thus, a body-centered cubic unit cell contains 2 atoms of an element. Calculation of number of atoms per unit cells in face-centered cubic unit cell. In a face-centered cubic unit cell, there are 8 atoms at the corner positions and 1 atom at the center of every face of the cube. As each atom at the corner position contributes 1/8 to the unit cell, the contribution of these 8 corner atoms to the unit cell is 1 atom. Each atom at the face center is shared between 2 adjacent unit cells. Thus, the contribution of 6 such face-centered atoms to the unit cell is 6 into 1/2, which is equal to 3. Therefore, the total number of atoms per face-centered unit cells is 1 plus 3, which is equal to 4. 8 corner atoms into 1/8 is equal to 1 atom. 6 face-centered atoms into 1/2 atom per unit cell equal to 6 into 1/2, which is equal to 3 atoms. Therefore, total number of atoms per unit cell is equal to 4 atoms. The face-centered cubic unit cell contains 4 atoms of an element. The three-dimensional